In this lesson, we're going to learn how to simplify expressions involving negative exponents. And here are some of the Common Core standards that this lesson is aligned to. So here we have negative exponents, and we're not even going to look at this key concept yet. That's really for you guys to write on your index cards for tonight's homework. But let's just analyze this problem here, c squared divided by c to the fifth. Now, if we were to follow our division rules like we learned already, we would say c to the 2, take away 5, and we know, because we are mathematically proficient, that 2 take away 5 is negative 3. Now, we really want to know what this piece means. What does it mean to be c to the negative third power? Well, let's take this problem again, and let's expand it. C squared means c times c, and c to the fifth is c times c times c times c times c. And remember, every time I see a number or a variable on the numerator and on the denominator, I cancel it out. So I'm going to cancel out these two. And there's nothing left on top. But that doesn't mean that it's a 0 on top. It means that it's a 1 on top. There's nothing up there, but the 1 is that placeholder. So really, this is 1 over c times c times c, which is 1 over c cubed. So c to the negative 3, the negative third power, has to really equal 1 over c cubed. And that's what this property tells us, that when we have a negative exponent, so if I had x to the negative 2, to make the negative go away, I put it in a fraction underneath 1, and I make my exponent positive. That's all that this property really tells us. So here, again, imagine I had x to the negative 2. Well, I could rewrite that as 1 over x to the positive 2. These are called reciprocals of one another. Okay, but here's another way to think about it. Well, what if I had 1 over x to the negative 2? That's kind of opposite of what we were used to seeing. So I can bring the x to the negative 2 out of the denominator and make the exponent positive. So just keep that in mind as we move forward. So here are some examples that we need to be able to work with. Remember, an expression is completely simplified when it contains only positive exponents, each base appears exactly once, there are no powers of powers, and each fraction is in simplest form. So if I wanted to get rid of the negative exponent in this expression, y to the negative 7, I would write it as a fraction, where 1 is my numerator. I put y on the denominator with a positive 7 as its exponent. In my next example, 3x all raised to the negative first power. I would put 1 as my numerator and 3x to the positive 1 as my denominator. And again, I could write that as just 1 over 3x, but either one is fine. Our next example is slightly trickier. So I have negative 6q to the negative 2. So you have to be careful here. In this second example, the negative 1 was for everything in parentheses. Here, the negative 2 is just for the q. So I'm going to keep my negative 6 here, and I'm going to multiply by, now let's flip this q to the negative second power as 1 over q to the positive second power. And now if I were to multiply across the top, I would get negative 6 over q squared. My last one is very similar. Negative 18, a squared b to the negative third power. That negative 3 is only for the b. So let's write ourselves a negative 18a squared, because I'm doing nothing with that. And now let's multiply it by, how can I change this b to the negative 3? Well, it becomes 1 over b to the positive 3. So 1 over b to the positive 3. And now I multiply across the top. So negative 18a squared times 1 is negative 18a squared all over b cubed. And now I have no more negative exponents, and my fraction is in the most simplified version that it can be. Okay, so that is our lesson on negative exponents. We are, of course, going to extend this tomorrow in class, but please make sure you're writing an index card to help you remember what the rule is for negative exponents. And fill out the Google form. Have a good night.